Welcome to screencast session on week 7 AVL trees. So now we are working with the part 2. The implementation of part 2, it includes that other functions. So where the part 1 we have done it that inserting the left rotate, right rotate. So now we are doing that. So other functions which are required for the AVL tree. The first function it's required for this one is that rebalancing. The balancing factor, every time you have to rebalance it. So based on the rotation. So let's do that. If self dot, so left is none, so where you don't have that any vertex, so any node, so then the height left is going to be the 0. So otherwise, so you might have some kind of height there, so that we are updating, that is else, so that height left is so self dot, so left dot height. So we are getting that, so left subtree height. So similar lines we try to do that, getting of that right subtree height also. So we are checking that, so whether my right subtree also, whether it is none or not. So the right subtree, if it is none, so the height right we are getting. So if that is height right is having something other than the none, so then we are getting the height of the right subtree. So we got that HL and we got the HR. So let's do that. So which one is highest? If HL minus HR, if it is greater than 1. So what does it mean is, so the left subtree is highest, so higher height. So where it is higher height is there, so then that right subtree. So at that time what you do is, so if self dot, so left and its left subtree, so what the height it is having, if it is greater than self dot left, so and its right height, so if the right height is, if it is smaller than that left height, so at that time we try to do that, so right rotate. So already we have a right rotate one, so which you have implemented earlier, so that we are calling it, here it is, yeah, here it is, so right rotate. So this is we have done so far for that, whenever that left subtree height is bigger than that, so right subtree height. So still we are continue. There might be a reverse criteria. So what we do is, so we have that, so left subtree height is there, so its height is less than, so right subtree height. So then what you do is, we try to do that, instead of the left rotate we try to do that, sorry, right rotate we try to do that, so left rotate. So this is that similar kind of calling. So after doing that left rotate, so you supposed to do that right rotate also, that is self dot right rotate. So we have to do that both left rotate and right rotate whenever that left subtree height is less than the right subtree. So after doing it, so we try to update the height. So this is self dot update height. So this update height is a separate function. Of course, you call it later. And now the same thing you're copying. So whenever the right subtree is having more height, so whenever the more height is there, the right subtree, we are getting a negative value that's greater than -1. So that means that, so right is having higher height. So at this time, so the right height left is, so whatever the right left height is, if it is less than, if it is maybe first time you're checking it's a greater than and less than. So if this is less than, so that is right height. So then what you do is left rotate instead of the right rotate. So this is what the first part of it. And now the second part is, so the right left, so whatever the right left height is there, if that is greater than, so that so the similar lines of right height, so whenever this is smaller, so the right height is smaller, so at that time we try to do that right rotate. So the right rotate of it, so let's do that right rotate of that left subtree, correct, yeah. So after that the left rotate, so this is what the left rotate. So similar lines here, the left rotate is definitely, so left rotate. So whenever that the left is less than that, so left rotate. So possibly we have done it, and similar lines we need to update the height again. So this is possibly the function number 6 we have implemented. So this is a rebalancing one. So every time you need to update the height in terms of that is if self dot empty, so that is empty of that, this is empty, then we return nothing, so we don't do that any operation. So else we do that, the common set of operations we do is, so that is self dot left update height, we do it, the left height is updated, and similar lines that we have to update that, so height of the right subtree also, which is frequently we do it, so which is recursively we do it, and similar way, so we need to get it the new height value, that is 1 plus the maximum of, so self dot left height, and we have the second one is that right subtree height. Out of these two, which one is a maximum? So that maximum plus 1. So that's we got it. So this is a function number 7, which is frequently called by the function number 6. And later on, so we have that traversal of the tree. So as usual, we have the 3 kinds of traversal. We have the left root right is there. That's called in order. Mostly it is a sorted order of output. If self dot is empty, when it is empty tree is there, we return that a simple kind of empty list, because we don't have any elements to return. So otherwise, what we do is we try to return, there is a recursive calling of, so left traversal, which is in order traversal of the left, and then plus whatever the value of the self dot value, that's a list element, plus so self dot, so right dot in order. So because we are traversing that left subtree, we are traversing the root, then we are traversing the right subtree. The same thing if you copy it, where you are having the pre-order, the root is processed first. When the root is processed first, so this value will become the first one, so that it's going to be the first one. Then after the value of the root, we try to traverse that left subtree, then we try to traverse the right subtree. Same way, when it is post order, so we try to process that root is at last. So here, so this value of this particular one, we try to process at last. So this is at last. So this is what actually AVL tree. Let's run it. Yeah, so we are giving the input values, which I'm giving is unsorted elements. So 4, 23, 1, 7, and 9. So let's see that. Oh, there might be some kind of issue where it is none type object has no height. So which could be the line number 96. Yeah, it's a perfectly, there is a fix is required. So the 96 is, so where you are having whenever that, oh sorry, it is less than the -1. So it is possible is this. Yeah, it is because we are expecting greater height for it. So 45, 2, 4, 1, and 7. So let's see that. Yeah, got it. See, look at that. That in order traversal is always sorted order. So we got that 2, 4, 7, 45. Because 2 is entered twice, it's not allowed in BST. You know that. Always the values are unique. So whenever that, if you come with the reverse order of that pre-order, which is root is processed first. When it is post order, the root is processed last. Here the root is processed last. So hope you got it. So thank you very much. Have a nice day.